Okay, so the question is this lead 4.1 option 1 daylight availability simulation accurate? Here's the basic design that I opened when I saw when I opened the file. A couple things that I noticed immediately is, and I've already changed this. Let me turn off the simulation. This floor was not part of the floor layer, so always a really good practice to get into is to turn on and off layers that you think are, surfaces that you think are on a layer. Check and see if they're there. The other thing is always make sure that you are, applying materials to the layers that you think you are. So that's the baseline things to check. Something basic that I notice people doing that I don't really get. I'm going to turn on your site plan. You call it the new site plan. My building's right in the middle of some buildings, or your project's right in the middle of some buildings. Here's your site right here. So why is this project not in that site? Why is this not here? At least it's facing the correct direction. So in a way, we're fine. But I mean, these buildings are going to create a lot of shade, right, on this project. So this already is not an accurate analysis. But that wasn't the assignment. The assignment was just to get it working. So just wanted to point that out. So our baseline, or the analysis, the simulation that we started with was this one, and the question was whether or not it was working. Like I said, it's important that everything be in the right layer. So I changed, I set this on the floor layer. That could have an effect, though. The way you've modeled these, it's driving me crazy with turn this off. The way you've modeled your surfaces is they're coming right to the edge. Let's look at that. The edge of your exterior wall surface. So if I get rid of these windows, we see that you're actually modeling your daylight surface all the way to the outer edge of this wall. So part of that surface is in the wall. That's not really going to be the most accurate thing, right? We want to have this inside the building. I typically bring the edge of my work surface a foot or so inside the interior of the wall. So that's one thing, a small detail. But anyway, the question is whether or not this was accurate. One way I check that, and actually I ran it again to make sure that the glazing was what I thought it was. So I have the same results here as your first run, and I ran this with visible transmittance 91% glazing. So we're starting with a glazing that has a very high visible transmittance, 91%. So the first thing I did to test this simulation was then I ran, because there had been some question about whether or not we had the right materials chosen. That was adjusted when we were talking about this in class. Right, we had. So I feel now comfortable with these materials we've chosen. I actually changed. This is a new glazing that we'll get to in a second. So I ran this with a visible transmittance of 30% glazing, and we got a pretty strong change. So I do think this model is working fine. It's just that this is a pretty, if you think about it, so this room right here, or this space, is about 25 feet wide, and I think it's 21 feet. This glass is, 21 feet tall. So it's just a really tall piece of glass in a pretty thin room. That's going to cause a lot, and it's facing south. That's going to create a lot of light. So I think that's what we're seeing here. And so I just did a little bit of iteration. I decided, well, I'll try to fix this to some degree with some shading. And initially I just put a little bit on the south. I mean, one piece on the south side to test it, and but finally added all these. And I think this is, I guess this is a double height space. If that's true, then I probably, I still might want to. Well, maybe I'll even just do that in a second. So I ended up with the first shading run is this one. So I went from, so we're going from the baseline with just the 0.91 VT glass to about a third of that, 0.3. A big improvement in terms of lead daylighting. We still have crazy amounts of lux here, and so the lux being for thinking about the work surface, what we're doing in the space, and then we still have just a lot of spaces that have too much light from a lead standpoint. Switching to a little bit of shading, we do cut into that a bit, and then if I go to, so let's go 0.91, 0.3 VT, some shading, and then shading on the full building. We've made a huge difference between here and here, right? And these light levels are decent for a usable space, so I think we're doing well. Right at the edge, it's bad in terms of it's going to be a lot of glare there, too much light. Down here we have a lot of extra light, but this could be a quarter. I don't really know what these spaces are for. So the point is, I think this model is working, and I'm able to make some headway with some shading. Of course, that may not fit your design goals in Studio. So moving forward, maybe perhaps the thing to think about next time is, if you that could be a problem, right? Because if you had a client who needed or who wanted you to meet a certain daylighting, and plus, daylighting we've talked about, it's useful, it's necessary, it's energy efficient. So why would we create designs that are fighting it unless we have a really good reason to? I'm going to run this one more time. Let's see. I just added a little bit more shading here to see what would happen. Because I think this is a double height space. This could be an exterior light shelf or it could be an interior light shelf. You can move it inside. So the results, yeah, see that, I added that second layer of shading here. That helped a lot with that. We're actually, what space is this? This is the, well, this is also one large area. I kind of doubt that would be true. I think this would be split up into different spaces. Still have a huge amount of ASC here because of this space, which is west facing, which would take more than just these horizontal shades to deal with. Anyway, that's the process for thinking this through. The model is working, and I hope this helped.